All right, I can explain Boyle's Law. If given pressure and volumes, I can use Boyle's Law to mathematically calculate the missing pressure or volume. When we buy bottles of gas, we say that the gas is compressed. Why? If I have here an air tank used for scuba diving, and the air tank says 5 liters, that tells me the volume of the air tank. How much air, breathable air, will be in that 5-liter tank?
2.
Minutes. Tell me how many minutes you think of breathable air.
30.
30 minutes? 50 minutes? Probably about 2 to 5 minutes.
Oh my God.
Why? Well, I mean, that ought to tell you right there why we do not measure scuba diving tanks in volume. Because they're all the standard volume. You will have the same volume once you return it back to the scuba diving center as you had when you took it from them. You can have 2 minutes of air in there, or you can have an hour worth of air. Gases will take up whatever volume they live in. You can have 3 molecules of gas in this room, and they will be taking up this much volume. Or you can have a bazillion molecules of air, and they still would have the same volume. Gases take up the volume of whatever container they're in. So, they cannot measure gases using volume. They have to measure it using pressure units. Why? Because the higher the pressure, the more air you have. What do they have to do? Okay, so they put in 2 minutes worth of air. What do they have to do to that air in order to create more space for other air? Compress it. Compress it. Best way to think about this is, have you guys ever used a hand pump
Oh, like basketball.
for basketballs? Okay, so when this fills up with air, right? So when you pump it, you're squeezing the air into the basketball. That's called compression. Okay, that basketball has the same volume. Doesn't matter how much air is in there. You could have a basketball that will not bounce anymore. It still has the same volume. You're going to have to shove air molecules in here in order to increase their pressure. So when you're buying scuba tanks, what you want to buy is either by mass or by pressure, telling you how much air is in there. Okay, usually you have a little gauge, and that gauge is measuring pressure. And the more pressure you have, the more breathable air you have in there. So you buy compressed gas. Gases will attain whatever volume of the container it is in. Only by stuffing a lot of gas in the same volume can you get a sufficient gas for your needs. So, what happens to the volume of a balloon when you exert pressure on it? It gets so when you put pressure on it, the balloon gets bigger.
Well, it depends on where you
Gets smaller. What happens when you double the pressure on a volume of gas? It's halved. It's halved. What happens when you have the pressure on a volume of gas? The volume of gas, volume is doubled. Are you beginning to see a pattern here? Whatever you do to one, what are you doing to the other? The opposite. The guy who first described this, he didn't really invent it because it had been around for a long time. The guy who described it was this guy who was an honestly nice guy. His name was Robert Boyle. And he was Boyles, Boyles. He was a really nice, sweet guy, unlike Sheldon Cooper, unlike many scientists who can be rather arrogant and haughty. What is Boyle's Law? As pressure goes up, volume of a gas goes down, and vice versa. As pressure goes up, volume goes down. As pressure goes down, volume goes up. So, let's look at the syringe. The syringe has 8 milliliters of gas. What happens to the pressure if all of a sudden you now only have 4 milliliters of gas? What happened to the volume? It was, okay, it did get smaller. By how much? Okay, so it was halved. So the pressure was doubled. The pressure was doubled. This graph shows an inverse relationship, which is exactly what this is, an inverse relationship. So when the volume is this much and you double the pressure, guess what happens to the volume? The volume is halved. All right, let's do this one right here. It's easier to. Okay, so when you're going from 0.020 to 0.40, right? 160. Is that right? Did I do this right? 0.0. Oh. I'm sorry. 200 to about 100. So when you double the volume, you have the pressure.
In a demonstration of Boyle's Law, we'll place a balloon in a vacuum bell jar.
Okay, so a balloon's volume is going up. What must you be doing to the pressure? Going down.
We'll apply a vacuum, which basically pumps out the air in the bell jar. The pressure outside the balloon will be greater than the pressure inside. The balloon expands to try and equalize the pressure. Volume and pressure are inversely related to each other. When we release the vacuum, the pressure increases.
Okay, the balloon volume is going down. What must you be doing to the pressure?
And the volume decreases. As another demonstration of Boyle's Law, we will put a marshmallow peep into our vacuum jar. The marshmallow.
Okay, what's going to happen to the peep? I mean, for example, he's got this peep, and he wants to share it with the class, but it's only one peep. So what do? You stick it in this vacuum chamber, and
It contains air trapped in a mixture of gelatin and sugar. As we apply the vacuum, the pressure outside is lower than the pressure
so
inside.
now you have enough
the air in the peep will expand to try and equalize the pressure. When we release the vacuum, the pressure increases and the volume decreases. As another.
Okay, so explain why the peep increased in size. Marshmallows are puffed with air. There's air inside the marshmallow. Okay, so as you decrease the pressure, then the volume inside increases. Now, here's a question. The mystery, though, is what caused the peep to get smaller than it originally was once you put the pressure back in? Any theories? Yes, Jeff.
Because at some when you increase the pressure, it compromised the marshmallow's integrity, and therefore when it decreased, it would deflate further. Because it would have an increase when you release the pressure so fast that it compromised it.
What do you mean by compromised? What do you mean by compromise the integrity? I mean, it's a liar now?
What? No, it got weaker.
Okay, so there's gas bubbles in there. What happens to the fibers when you cause it all to expand? They stretch. If some of those fibers break, then what happens to some of the air inside? It escapes. So what you're seeing is the fact that some of the air escaped from the PEEP when you were stretching it out. Okay, this is shaving cream.
Illustration of Boyles Law, we'll put some shaving cream into our vacuum jar. The shaving cream contains air trapped in a soap mixture. As we apply a vacuum, the pressure outside is lower than the pressure inside. The shaving cream will expand to try and equalize the pressure. As you decrease the pressure, the volume increases.
Why does it grow? Shaving cream is full of air. Okay, so when you decrease the pressure, the volume of air inside increases. Yeah. Okay, what is the formula that we will use? P1 V1 equals P2 V2, where pressure and volume 1 are the conditions before you mess around with it, and pressure and volume 2 are the conditions after you've messed with it. You will need that equation to solve the following questions. A 2.50 liter, what's that? 2.50 liter. Sample of gas at 1.5 atmospheres. What's that? Has its pressure reduced to 0.75 atmospheres. What's that? What will be its new volume? Take out calculators. I forgot to tell you, we're in chemistry. You should always have what two things on your desk? Periodic table and a calculator. All right, this looks like a simple algebra problem. Multiply those two numbers and divide both sides by 0.75. Oh wait, you don't really have to. Because if you understand the concept, what happened to the pressure? It was halved. So what must happen to the volume? It must be doubled. Now, they're not always going to be that easy. Okay, so you do need to learn to use the equation. All right, how about this one? A 3 liter of a gas. What's that? P1 V1 equals P2 V2. 3.00 liters. At a pressure of 1 atmosphere. What's that? Equals. What will be the new pressure? That's X. If the volume is decreased to 1.50 liters. Look at this one. Is this one easy enough to do in your head? No. What happened to the volume? So what must happen to the pressure? All right. So 1 times 3 is 3 divided by 1.5, 2.0 atmospheres. However many decimal places they give it to you, please give it back to them in that many decimal places. Don't go crazy with your calculator. Here's one where you have to use a calculator unless you're really, really good at math. A 5.60 liter sample. What's that? At 3.5 atmospheres. Has its pressure reduced to 1.0 atmospheres. What is the new volume? Multiply 3.5 by 5.60, divide by 1. you lowered the pressure, what should you expect the volume to do?
Higher.
And it looks like you lowered it by about a third, right? So you should triple the volume, so it should be around 15, a little more than 15. What is it? Who's got it?
Yeah, that's what I got. 19.6.
Okay. Let's see if you can now answer these thinking questions. Even when provided ample oxygen gas to breathe, aircraft passengers become uncomfortable if the cabin loses pressure. Why? Okay, let's talk about ears popping. It's caused by the Eustachian tubes. You have called people airheads, probably in middle school, but the fact is, we're all airheads. We all have a lot of air in our sinus cavities. The Eustachian tubes' job is to make sure that the pressure inside our heads is equal to the pressure outside our head. So if the pressure outside is too much, what happens to our ears? They pop in order to let air in. If the pressure inside our head is too much, they pop in order to let air out. Okay, keep in mind that most of what air is nitrogen with a little bit of oxygen. So most of the air pressure is caused by nitrogen. So what happens if the airliner decides just to give you oxygen and take out all the nitrogen? What happens to the air pressure inside the cabin? It gets lower. You may have enough oxygen, but our ears will be very, very unhappy. It might actually, that kind of rapid decrease in air pressure could cause damage to our eardrums. Okay, so they actually pump air, not just oxygen, air into the cabin. Every airplane has a storage of air, and they pump the air into the cabin in order to keep it roughly equal. It's not going to be equal. They can't afford to pump that much air, and you don't want that much air inside the airplane, because when it gets really high up there, the airplane is just basically a rigid balloon, isn't it? The pressure inside will become too great. So they can't pump it full of normal air. That's why when you come back down, you'll feel it pop as the air pressure outside begins to get back to normal. But they do have to pump enough air in there for you to be comfortable. Okay, how about this one? What makes a cola refreshing? Yummy.
Carbonation.
The carbonation. Actually, it's just carbon dioxide bubbles in there. Normally, the carbon dioxide bubbles want to get out in our air pressure. So what do they have to do in order to keep the bubbles in?
Pressure.
Pack it with extra air, about 5 times more. Okay? So when you pop it open, what happens? The air escapes. Okay, and eventually what starts happening to your cola? Now you're on a clock, don't you? It goes flat. This is called a fizz keeper. And you can buy this at Walmart. If you have a small family and that 2-liter may stay around for a while, what you want to do is buy the fizz keeper, take the lid off when you first open it, throw it away, actually recycle it, and replace it with this. And every time you use it, pump air back into it until it's nice and plump again. And that will force the carbon dioxide that had been trying to get out, that'll force it back in to your drink. It's called a fizz keeper. How about this one? Tennis balls are sold in pressurized cans. It's in order to give the tennis ball its smell. Okay. Who's ever played around with a tennis ball that's been around for a while? Bailey, what's it like?
Like, I
That's been around for a while?
don't know.
An old tennis
It's,
ball.
Really, like, discolored and,
Okay, and is it as bouncy?
no.
No. The fresh ones are bouncier because there's more air inside. So how do they keep the air inside the ball? Because, you know, who knows how long ago that ball was made. So in order to keep it bouncy, they have to put air inside the container. Over time, what happens to the air inside the ball? It leaks out. All right.